All right, so we're gonna go over addressing. All right, so for this, I am going to actually share my whiteboard and explain everything the way I see it before we go through the chapter. So hopefully it helps you as you read on. Let me connect one more time. Admit. No sound. And let me share my whiteboard. All right, let me stop sharing here. Give me a second, guys. Bear with me. All right. Okay. So we're gonna be talking about how you read the IP addresses and when you add the network card, okay? So every packet, I already went over this, needs to have a source IP address, and a destination IP address. This source IP address and destination IP address are gonna help you know what your initial device is, specific, what device is sending this information, and what device is the final destination for this packet. And the final, because again, there could be many devices on the network between that one computer. We're gonna call this computer 1 and computer 2. This computer can be connected to a switch represented by this symbol, and this switch can be connected to a router, and between that router can have many connections to other routers on the network. All right. So the source IP address is gonna be the IP address for this computer, 192.168.10.10. Destination IP address is gonna be 192.168.10.11, let's say, right? So that source IP address and destination IP address that can be labeled on this envelope is not gonna change ever until it arrives to that device over there throughout the entire process of communication. So when it gets to a switch, it's not gonna change. When it gets to the next router, it's not gonna change. When it gets to the next router, it's not gonna change. This IP address, this label is added to this envelope in the internet layer, okay, or the network layer, internet layer, network layer, okay. If you're talking about the OSI model, it's gonna be on the network layer, third layer, layer 3, okay. But when it gets to the data link layer, you're gonna have a new address added to it. This is your MAC address, all right? This is important that you know the difference between them. So let's say this is my data link PDU, and here you're gonna have your MAC address, source MAC address and destination MAC address. Source, you guys can see this, right? Hopefully. Okay. Destination MAC address. All right, so this will change as you go through the network. When you add the source MAC address here, it's gonna be the MAC address when you're just sending the packet or the frame, when you just is getting out of the network, it's gonna be the MAC address. I mean, out of the computer, when it's leaving the computer, it's gonna be the source MAC address for the network card on computer 1. Okay, let's say this MAC address is A. However amount of numbers you have there, right? So that goes here. Now, destination MAC address is not gonna be the MAC address for this computer. The destination MAC address is gonna be for the device immediately receiving this packet after it leaves the computer. So that's gonna be the MAC address for the network card on this switch. And let's say this is B. Right? It's just an example. That's not an actual MAC address, right? So, okay, this switch is gonna receive the information. It's gonna look at the destination MAC address and the IP address. No, it's not gonna look at IP address, okay? The switches work on the data link layer. It's gonna remove the destination IP address. It's gonna remove the source MAC address, and then it's gonna add a new source MAC address and a new destination MAC address. All right, what MAC address is gonna add? It's gonna add its own MAC address. And then for the destination, it's gonna add the MAC address for the next device receiving this packet after it leaves the switch. All right, and that's gonna go here. All right, the router, the routers work on the layer 3 or the layer that's in charge of IP addresses. So the router is gonna get the bits of information, ones and zeros, right? It's gonna get that package and de-encapsulate it. It's gonna take a look at the MAC address. Well, not yet. It's gonna go to layer 3 and look at the IP address. Where's the destination? The final destination. The reason it does this is because each router has a table, all right, with different networks. So it knows, okay, this network connects to this router over here, connects to a router that's connected to another router that's connected to the network that I need to send this packet to, all right? So each router has it has a table of different paths to different networks. That's why it has to go to layer 3, de-encapsulate until it finds that label with the destination IP address, so it knows which path to send the packet through. Right, so it knows which router it needs to send, information to arrive to the final destination. After it finds out what the final IP address is, it's not gonna change that. It's gonna leave it like it is because the next router needs to know this information too. What it is gonna do though, is gonna go down to the data link layer and it's gonna remove the MAC address that was there already and add a new MAC address and a new destination, a new source MAC address and a new destination MAC address, right? Which MAC address is it gonna use? Well, for the source, it's gonna use its own MAC address. For the destination MAC address, that's gonna depend. Is it gonna send it to that router over there, or to this router over here, or to this router over here? If it's gonna send it to this router, then it's gonna use the MAC address for that router. And this process is gonna continue all the way until it gets to the switch, the final switch, and then the final computer. Any questions about this? Just remember, all you need to remember right now is one, the switches are gonna have a MAC address table, so they know all the MAC addresses that are connected to the different interfaces on the switch. Now this MAC address table is temporary though. So whenever you first communicate from one computer to the switch, it's gonna record that MAC address saying, okay, I have this MAC address on this interface. And that computer is gonna be looking for a specific IP address or MAC address on the network. So the switch is gonna send a broadcast, who has this MAC address? And then after a computer replies or router replies, it's gonna record that MAC address and save it on the MAC address table for further communication. But after 5 minutes or 2 minutes, it will remove everything on there. We'll go over that later. But for now, MAC address will change as the packet travels from one device to the other one. The IP address will not change. It's gonna be removed until once it gets to the final destination, right? Because every device, every router on the network needs to know what the IP address is. That is the basic concept that you need to remember. All right, I am going to stop this sharing and go back to sharing my screen on the computer. Now we can move on without me having to explain much on the actual chapter. Share screen, go here, go here. All right, so first, any questions about what I just spoke about? All right, again, I'm looking for that timeout. If I don't receive a reply in a limited amount of time, I'm continuing. All right. So let's start with this. As you learn, it is necessary to segment messages in the network, But those segmented messages will not go anywhere if they are not addressed properly. Each one of those segments is going to have an IP address and MAC address. This topic gives an overview of network addresses. We'll also get the chance to use the Wireshark tool. So whenever you're using Wireshark on the lab, you'll be able to see the source IP address and the destination IP address on there. You'll be able to see the different labels and the different codes that are on each label that are on that packet or frame that is being sent through the network. The network and data link layers are responsible for delivering the data. Remember, network and data link. This is your layer 3 on the OSI model and your data link layer. Layer 3 on the OSI model is in charge of the IP addresses. The data link layer is in charge of the MAC addresses, adding those labels to your data unit. Network layer source and destination addresses, responsible for delivering the IP packet from the original source to the final destination, which may be on the same network or remote network. Data link layer source and destination address, responsible for delivering the data link frame from one network interface card, one NIC card to another NIC card on the same network, okay? Physical layers in charge of time and synchronization, data link layers in charge of destination and source physical addresses, network layer is in charge of destination and source logical network addresses. Logical, remember your IP addresses. Your physical addresses are your MAC addresses. And again, physical layer is talking about the network cards. They're in charge of timing and synchronization, transport. And again, this is just a few of the jobs for each one of these layers. Transport layers is in charge of destination and source process numbering. Remember that this is where your segmentation happens and numbering for each segment. Upper layers, encoded application data. All right, moving on. Logical addresses, again, this is going over the IP addresses. You need a source and a destination IP address on each packet that is sent through the network. I'm not going to explain this. I just explained it on the whiteboard. All right, so every IP address is divided. So you'll see a group of 4 numbers on there, okay? These numbers are going to give you different information. For example, if you have a class C IP address, your subnet mask is going to be 255.255.255.0. Where that 255 is will tell you that that octet is the IP address for the specific network you're in. So this is a class C. So that means that this first 3 octets is the specific IP address for the actual network you're in. Think of this like your zip code. What zip code you're in, what zip code is your housing, all right? Remember the zip codes is a group of addresses, right? Does it kind of make sense? Well, the same thing happens in IP addressing, all right? Each zip code is gonna have a specific number to it. So each network that you're in, each network on a group of networks is gonna have a different IP addresses, all right? So for a class C, the first 3 octets on that IP address is the actual address for the network itself. And the last address there, denoted by the subnet mask with a 0, is gonna be the actual individual address for the computer. So, an example, you can have 2 computers that are part of the same network. If they're part of the same network and it's a class C network, both computers, the IP address for both computers is gonna start at 192.168.1. So one computer might be 192.168.1.110, and the other computer might have 192.168.1.111. The only thing that's gonna change is the last portion, the last octet of that IP address. The other 3, the ones that stay the same, is the IP address of the network you're in, okay? Routers use this information to find out what network the final destination is in, okay? That is what this is talking about. An IP address contains 2 parts, the network portion and the host portion. The network portion, the leftmost part of the address that indicates the network in which the IP address is a member. All devices on the same network will have the same network portion. The host portion, the remaining part of the address that identifies a specific device on the network. This portion is unique for each device on the interface on that network. All right? Subnet mask IPv4 or prefix length is used to identify the network portion of the IP address. So each class of IP address is going to have a different subnet mask. When you're talking about IPv6, it's not going to be known as a subnet mask. It's going to be known as a prefix length. Any questions about that? Do you need to see it on the whiteboard? And we're going to go over this again. I just showed you the different classes there are. And really, that's all you need to know right now. In this example, we have devices on the same network. And again, we're going, in this example, we have a client computer sending to another computer or server on the same network. You can see that both IP address, the 3 octets, the first ones on the left, are exactly the same. This tells the switch or the router or you, the user, that they're on the same network. 192.168.1, 192.168.1 over here. The last octet tells you the specific unique IP address for the specific device. This computer has .110. This computer over here, the server, has .9 at the end. This identifies the device on the local network. All right. Now, when it comes to MAC addresses, these MAC addresses have to be unique on the network, on the local network, and if you're going outside the network through the internet, it has to be unique everywhere you go, pretty much. Source IPv4 address, the IPv4 address of the sending device. Destination IPv4 address, the IPv4 address of the receiving device. All right, moving on. Role of the data link layer address. I went over the role of the data link to add the MAC address to that packet, right? The source MAC address, destination. And that MAC address is gonna change as it goes from one device to the other one. When it gets to the switch, if it's going to the next device, if it's computer, then it's gonna add the source IP address or MAC address for that switch, and the destination is gonna be for that computer. If it's going to the router, then the source is gonna be that switch, and the destination is gonna be that router. And as it goes from that router to the next one, that's gonna change again, and it's gonna change again, and it's gonna change again until it gets to its final destination. The one thing that doesn't change is the IP address. Source MAC address, this is the data link address or the Ethernet MAC address of the device that sends the data link frame with the encapsulated IP packet. You should now understand what encapsulation means. Destination MAC address. When the receiving device is on the same network as the sending device, this is the data link address of the receiving device. The destination MAC address is the MAC address of the FTP server here on this example. All right, we're moving on. Device on the remote network. I think I can skip this. I've gotten information for that. A role of the network layer address. This is the IP address that you're going to be using. This will not change as it traverses through the network. The IP address is going to stay the same. The source IP address is going to be the same. This is where the message originated. The logical address, right? The destination, final destination IP address, that's going to stay the same. This is the final destination of the receiving, the final IP address of the receiving device. And you can see here the packet as it travels. This device, the IP address, each device is going to have its own IP address and MAC address. That's all it's saying here. All right, moving on. Role of the data link layer address, different IP networks. Okay, so if you're in different networks. When the sender and receiver of the IP packet are on different networks, the Ethernet data link frame cannot be sent directly to the destination. Again, it's just going over. Yeah, that's fine. This is just going over how the MAC address has to change when it's going to a new network or a different device. I went over this. There's just going to be examples of this happening. All right, we'll move on. You'll see a better example next. The Ethernet frame with the encapsulated IP packet can now be transmitted to R1. Okay, moving on. Same examples I've already given. Data link address. The data link layer 2 physical address has a different role. The purpose of the data link address is to deliver the data link frame from one network interface to another network interface on the same network. Before an IP packet can be sent over a wired or wireless network, it must be encapsulated in a data link frame so it can be transmitted over the physical medium. Router to router, router to server. Let's look at this. Same thing I've covered. I'm going to skip this. And again, it's a lot of information. You just need to know the basic overview of it.